Question 10. A student added 625 milligrams, or 0.627 grams, of hydrated sodium carbonate, and it gives you the formula Na2CO3XH2O. Doesn't tell you what the X is, maybe we've got to work that out. To 200 centimetre cubed of 0.25 mole hydrochloric acid. This gives me a clue. I've been given a volume of hydrochloric acid and a concentration. It wants me to work out moles. Let's do that first of all. Concentration 0.25 equals moles divided by volume, but the volume's got to be in decimetre cubed, not centimetre cubed. So centimetre cubed up into decimetre cubed, up into a higher unit, a larger unit, divide by 1000, 0.2. So 0.250 equals moles divided by 0.2. Moles is 0.250 multiplied by 0.2, which will work out as 0.05. I do the same now, so I do the same now for the sodium hydroxide, just simply because I must have to. I've been given 0.150, a concentration of sodium hydroxide, and a mean titration volume for the sodium hydroxide. I must have to do the same. Concentration 0.15, volume 26.6, divide by 1000 to get it into decimetre cubed, 0.0266. Concentration 0.150 equals moles divided by 0.0266. So moles are these two numbers multiplied together. Moles is 0.150 multiplied by 0.0266 decimetre cubed. 3.99 times 10 to the minus 3. Now, sodium hydroxide and hydrochloric acid react in the ratio 1 to 1. HCl plus NaOH will make water, H2O and NaCl, 1 to 1. So the NaOH used in the titration is 3.9 times 10 to the minus 3. So the number of moles of acid needed is 3.9 times 10 to the minus 3. Okay. However, if we're talking about the whole sample, we've taken 25 centimetres cubed portions of the sample, and the whole sample, the whole solution, was 250 centimetre cubed. So we have taken a tenth of it. 250 divided by 25 is 10. We've taken a tenth. So we've worked out how much hydrochloric acid was left over in the 25 centimetre cube sample, but we need to times by 10 to work out how much hydrochloric acid was left over in the 250 centimetre cubed sample. 3.99 times 10 to the minus 2. Okay, so 3.99 times 10 to the minus 2 moles of hydrochloric acid were left over in this 250 centimetre cube sample after I've reacted the hydrochloric acid with this. So I started with 0.05 moles of hydrochloric acid, and I've ended up with 3.99 times 10 to the minus 2 moles of hydrochloric acid. Why has the hydrochloric acid gone down? Because that's how much I started with, and that's how much now I've got. The reason is it's reacted with the sodium carbonate. So the hydrochloric acid has reacted with the sodium carbonate, then it's been titrated with sodium hydroxide to find out how much hydrochloric acid has been left. So if I subtract the two, the amount of hydrochloric acid that I started with and the amount of hydrochloric acid that I've ended up with, it ends up as 0.101 moles. So surely now I can use the 0.101 moles of hydrochloric acid that's reacted with the sodium carbonate to work out the number of moles of sodium carbonate. If 1 mole of hydrochloric acid reacted with 1 mole of this sodium carbonate, 1 to 1, the amount of sodium carbonate would equal the amount of acid that's reacted. But 2 moles of acid react with 1 mole of sodium carbonate. I know that because it's going to make sodium chloride, and I've got sodium chloride is NaCl, and I've got 2 NAs here and 1 Cl. So 2 moles of HCl will react with 1 mole of sodium carbonate. Or we could say 1 mole of hydrochloric acid reacts with half a mole of sodium carbonate. So this is the amount of acid that's reacted with the sodium carbonate. If I divide it by 2, it will tell me the amount of sodium carbonate that I've got in there, because 2 moles react with 1, or 1 mole reacts with half a mole. So now I know the number of moles of sodium carbonate that I've got, 5.05 times 10 to the minus 3. I also know the mass of sodium carbonate that I've got, 627 milligrams. Milligrams into grams, going up into a larger unit value, I divide by 1,000, 0.627 grams. Then moles equals mass divided by mR. Moles of sodium carbonate is 5.05 times 10 to the minus 3 equals the mass divided by the mR. The mass is 0.627. So 5.05 times 10 to the minus 3 equals 0.627, the mass, divided by the mR. With a little bit of rearranging, the sodium carbonate, the mR is 0.627 divided by 5.05 times 10 to the minus 3. It's that value there. That's the mass of the sodium carbonate, XH2O. If from that I subtract 106, that's the mass of 2 NAs at 23 each, 1 C at 12, and 3 O's at 16 each. It tells me how much of the mass is at XH2O. So if I take away 106, it comes out as 18. Now the MR of a water is 2 H's, 2 1's, and a 16, which is an 18. So the MR of a H2O is 18. I've got 18 left over. 18 grams left over. So an MR of 18 left over. The MR of a water is 18. So it means that I've got 1 water in there and X is 1.